Inside a government facility in California, the world's fastest computer is running right now. It fills a building the size of a football field. It uses enough electricity to power a small city, and every single one of its 44,000 specialized chips was designed and built in America. Last month, engineers in Shenzhen, China, switched on a machine. They opened the doors of a facility packed wall-to-wall with black server cabinets. Cables ran across every surface like veins in a body. Liquid cooling pipes looped through every row. And somewhere inside all of it, 2.45 million processor cores began firing simultaneously. Not one of those cores was a GPU. Not one chip inside that room came from Nvidia. Not one came from AMD. Not one came from any company outside China. The machine ran anyway. My name is Iron Circuit, and by the end of this video, you are going to understand exactly what this machine is, why engineers around the world are staring at it right now, and what the numbers actually say. Not the headline numbers, the real ones, because they tell two completely different stories. Stay with me. Before we get to China's machine, you need to stand inside the one it is trying to beat. Walk through the main entrance of Lawrence Livermore National Laboratory in California, past the security checkpoint, past the badge readers and the reinforced doors, into a room the size of an aircraft hangar. That room holds El Capitan, the current fastest supercomputer on Earth. 44,544 chips, running simultaneously inside a structure that weighs hundreds of tons. Its verified, independently tested performance sits at 1.809 exaflops. 1 exaflop means 1 quintillion calculations every second. Picture every single person on Earth, all 8 billion of us, each one doing one math calculation per second by hand, without stopping, without sleeping. It would take 4 full years to do what El Capitan does in a single second. These machines are not built for anything ordinary. They simulate nuclear reactions. They model the Earth's climate decades into the future. They design new medicine molecule by molecule before a single pill is swallowed. Whoever controls machines like this controls something real. A scientific edge, a defense edge, an artificial intelligence edge, which is exactly why a locked door matters so much. And there is a locked door in this story. For years, the most advanced chips used to build machines like El Capitan have been banned from export to China. Trucks carrying them turned away at borders, shipments stopped at ports, documents stamped with red rejection marks before they ever reached a Chinese address. The logic was simple. No advanced chips, no advanced supercomputer, no closing the gap. China's engineers looked at that locked door for years. Then they stopped trying to open it, and they built a different room entirely. The machine is called LineShine. In Chinese, it is written Lingcheng, pronounced Lingsheng. It means intelligent splendor. It sits inside the National Supercomputing Center in Shenzhen. A city of skyscrapers and factory floors pressed right up against the border of Hong Kong. In April 2026, the center's chief designer, Lu Yutong, walked to a podium in front of a room full of engineers and made a statement. Every single component inside LineShine, he said, is Chinese. The processors, the memory, the storage drives, the network cables, the software. Not one part that any foreign government could block, ban, or cut off. Not one piece that disappears if a politician in Washington signs a document. The full design calls for 47,000 processors packed into 92 cabinets. The target performance is above 2 exaflops, and there is not a single GPU anywhere in the building. Now here is where most people's brain stops and asks the obvious question. How? Put a GPU card on a table next to a regular CPU processor. The GPU is bigger, heavier, has its own fans, its own power connectors. Inside it, thousands of small processing units all firing at the same moment, all doing the same type of calculation, simultaneously. Like a factory assembly line with 10,000 workers all turning the same bolt at the same time. That is what makes GPUs dominant for AI training. The math behind teaching an AI model to think is almost entirely repetitive. The same type of calculation, billions of times, on different pieces of data. The GPU factory floor handles that perfectly. A regular CPU is more like a small team of specialists, fewer workers, but each one can switch between completely different jobs without missing a step. For most of computing history, the specialist team was fine. Then artificial intelligence arrived, and the factory floor became worth trillions of dollars. So how does LineShine reach near the top of the performance ladder without a single factory floor in the building? 3 decisions, each one visible and physical. First decision, the processor. The chip inside LineShine is called the LX2. Hold one in your hand and it looks like any other server processor, a flat square of silicon roughly the size of a large postage stamp. But inside that stamp, engineers built something unusual, a piece of hardware called the Scalable Matrix Extension. It handles the exact type of repetitive matrix math that GPUs dominate, built directly into a chip that is still, at its core, a CPU. Like hiding a small assembly line inside the specialist's workshop. Each LX2 contains 304 individual processing cores, and LineShine runs 40,960 of these chips simultaneously. That is 2.45 million cores firing at once. Second decision, the memory. Every processor constantly needs data to work on. Normally, that data travels from memory chips sitting elsewhere on the server board, through cables, through connectors, across distances measured in centimeters. At the speeds these machines run, centimeters become a bottleneck. LineShine places high-bandwidth memory directly on the processor package itself. The distance from core to memory shrinks from centimeters to millimeters. Data arrives faster. Cores wait less. Performance climbs. Third decision, the network. 40,000 processors and 92 cabinets all need to talk to each other constantly. A custom interconnect network runs between every cabinet in the facility, moving approximately 10 terabytes of data per second across the entire machine. That is 10 trillion bytes every second. A fiber optic cable carrying information at a speed that makes your home internet look like a garden hose next to a river. Put all 3 decisions together. A processor with AI math built in, memory pressed directly against the core, a network fast enough to keep 40,000 processors in sync, and you get a machine that reaches near the top of global performance without a single imported chip. Now here is where I stop and give you the honest picture, because the headlines circulating right now are skipping a number that changes the story. The 2 exaflop target is the number attached to the complete 47,000 processor design. That machine is not fully built yet. The system running today uses 20,480 compute nodes. Its measured sustained performance sits closer to 1.54 exaflops. El Capitan's verified score is 1.809 exaflops. Put those 2 numbers next to each other on a piece of paper. 1.54 on one side, 1.809 on the other. LineShine today is behind El Capitan today, not ahead. There is a second number worth knowing. El Capitan's theoretical peak performance is 2.79 exaflops. LineShine's full target is 2 exaflops. Even when completed, the target still falls below El Capitan's theoretical ceiling. And there is a third problem. El Capitan's numbers come from Linpack, an independent standardized stress test that every serious supercomputer sits through, verified by independent engineers who are not employed by the machine's builders. LineShine has no Linpack score. China stopped submitting its supercomputers to the global ranking body in 2019. Every performance figure attached to LineShine comes from China's own engineers, China's own announcements, China's own publications. That does not mean the numbers are false. China built the Sunway Taihu Lite in 2016, a CPU-only supercomputer that held the world's fastest title for 2 straight years. Nobody seriously disputed whether it actually worked. But until an independent team sits down with LineShine and runs the standard tests, the honest label on the 2 exaflop claim is credible target, unconfirmed result. So if the speed record claim is shaky, why does this machine matter at all? Step outside the data center for a moment. Walk back to that locked door. The one with the red stamp that turned away every GPU shipment. The idea behind that locked door was simple. No advanced chips means no advanced supercomputer, means no closing the gap. LineShine is a machine built to prove that idea wrong. It is not a machine built to win a benchmark. It is a machine built to prove a point. That a country with a locked door in front of it can build a different door of its own and walk through it. A facility full of domestic chips, domestic memory, domestic networking, domestic software cannot be shut down by a document signed in Washington, cannot be cut off by a shipping ban, cannot be threatened by the next round of export controls. The machine is slower than El Capitan today, but it is immune to every lever that was supposed to keep it from existing. That is the actual headline. Not who is faster, who is untouchable. And here's the part of this story that makes it bigger than one machine in one city. Think about what a working template looks like, a blueprint sitting on a desk. Any engineering team in any country facing the same locked door can look at that blueprint. They can see the processor decisions, the memory decisions, the network decisions. They can adapt it. They can build their own version. LineShine is not just China's answer to a locked door. It is a manual for building around any locked door. And that manual now exists. Here is my honest read. Both reactions circulating online are missing the real story. The people saying China just crushed America and built the world's fastest supercomputer are reading headlines that the numbers do not support. 1.54 measured exaflops against El Capitan's verified 1.809 is not a victory lap. It is a strong second place with an asterisk. But the people waving this away entirely because the record claim does not hold up are making the more dangerous mistake. Because they are looking at today's scoreboard and missing tomorrow's blueprint. A fully domestic, GPU-free, sanction-proof path to near-exascale performance now demonstrably exists. That does not disappear if LineShine never officially takes the crown. The locked door was supposed to be the end of the story. LineShine is the beginning of the next chapter. So here's what I want to know from you. A door was locked to keep a country out of a technology. The country built its own door and walked through it. Did the lock work? Or did it teach the country to stop needing doors it does not control? Tell me your honest answer in the comments. I read every single one. If you want to follow this story as it develops, the independent benchmark tests, the full 47,000 processor build, and whether LineShine eventually earns the title it is chasing, subscribe to Iron Circuit and hit the notification bell. We track the machines, the decisions, and the engineering behind these headlines before the rest of the internet figures out what they are looking at. Thanks for watching. I will see you in the next one.